I'm here at the American Association for Cancer Research annual meeting here at the San Diego Convention Center. And what's striking isn't the innovation, it's actually the opposite. Science is accelerating, but the question is, how are we transferring all of this knowledge into clinical care? I'm Kathleen Barnes, and welcome to Precision Health Decoded. And that's really the tension I want to unpack. Because if you step back, AACR this year told two very different stories. One is about breakthroughs, new therapies, new technologies, new ways of understanding cancer biology. And the other was about something much less visible, whether any of these breakthroughs actually translate into care. And increasingly, those two stories are diverging. So let me start with the first story, the one everyone is talking about. We're seeing real progress against targets that were considered undruggable not long ago. KRAS is probably the clearest example of that shift. We're also seeing early but meaningful signals from personalized mRNA cancer vaccines, including diseases like pancreatic cancer, where outcomes have historically been really poor. At the same time, AI is converging with pathology, spatial biology, and multi-omics, giving us a much richer picture of disease. We're not just sequencing tumors anymore, we're actually reconstructing them. And perhaps most importantly, the field is shifting from minimal residual disease to multi-cancer early detection, or MCED, from monitoring recurrence to trying to detect cancer before it's even diagnosed. And that's where the second story starts to emerge. Because the earlier we detect cancer, the less clear it becomes what to do next. We're identifying signals earlier than ever, but the clinical pathways, the decision frameworks, and the downstream actions are not keeping pace. I want to pause on that for a moment because this isn't just theoretical. So for years I've heard, and many of you have heard, the same concern from health systems that false positives are dangerous, that they create anxiety, unnecessary procedures, downstream cost. And to be clear, those concerns are real. False positives do have consequences. But what's often missing from that conversation is the counterfactual. What happens when we don't detect something early? What happens when we delay, when we wait for certainty, when we optimize systems to avoid false positives, but in doing so, we accept missed or late diagnoses? I've experienced that tension personally, and it changes how you think about risk. Because ultimately, this isn't about false positives. It's about how we define acceptable uncertainty in medicine. And right now, many of our systems are designed to minimize one kind of error, even if it means accepting another. So when we talk about multi-cancer early detection, or more sensitive imaging, or earlier signals, the question isn't just how accurate are they? The question is, what are we willing to miss? The same is true for AI. We're building models that can interpret biology at unprecedented level, predicting outcomes, identifying patterns, even generating new insights. But we're not building systems that can consistently integrate those insights into care. In other words, detection is outpacing decision-making. And closing that gap isn't just about better models or more data. It requires aligning how evidence is generated, how clinicians actually make decisions, and how decisions are supported in real-world workflows. And to be fair, this isn't being ignored. There's real focus on validation, on infrastructure, on equity, on what it actually takes to bring these advances into clinical practice. But the fact that this work is so prominent tells you something important. the bottleneck is no longer discovery. If you step back, AACR is not just a story of innovation. It's actually a story of accumulation. We are accumulating signals faster than we're translating them into decisions. And that points to what's actually missing. What's missing is not another assay. It's not another model. It's a translation layer between discovery and care. A layer that doesn't just integrate multimodal data, but connects that data to decisions, to evidence that holds up with payers, and to workflows that clinicians will actually use. And critically, that work has to start early, not after the technology is built, but alongside it. So right now, that translation layer is fragmented. It's spread across teams, across organizations, and often disconnected from the point where the decisions are actually made. Which is why so many of the breakthroughs we see here, despite being real, they struggle to scale. And solving this isn't just a technology problem, it's a systems problem. Again, the bottleneck is no longer discovery, it's execution. Precision health will not be built by technology alone. It will be built by systems that turn data into decisions and decisions into care. Thanks for listening to Precision Health Decoded.